Okay, so this is our FSM, which is the finite state machine. It has 5 inputs, a clock, and 4 5-bit inputs that vary based on a mux, which we will see in the combined system. It outputs an 8-bit anode signal and a 7-bit cathode. The cathode signal goes through the decoder, which we instantiate over here. The state machine has 8 states that correspond to the 8 anodes that we are also using. This is our simple decoder, and it takes a 5-bit input and translates it into the appropriate cathode combinations. We can do a total of 32 combinations since it's 5 bits, but we didn't need all the extra values. We only needed the hex values and the extra degree symbol and L for our phrases. This is our combined system. It takes in all the combined inputs and outputs of our instantiations here. We have a bunch of wires going out of some modules and into others. This is the case statement that we use to vary the inputs into the finite state machine. So it's the temperature data or the ALU and the modes and inputs. We also assign the LEDs at the end to our temp data so we can visualize them. Also, a major part of this project was the I2C master, which I'll give to Anas to explain.
So the I2C master was a prefab code that we found, but basically this is what drives the performance of the temperature sensor. So you can see here it takes in these inputs. So basically the first input is going to be the clock input. This reset signal is something that we didn't use, but this basically maps to a button which allows, like on the board, which just resets the signal. So the SDA, so this is an in-out. I thought this was kind of interesting, but it's basically called a bidirectional, it's called a bidirectional signal, which is, this is just for like the data line. This output is our 8-bit temp data output, where the most significant 4 bits are the 10s, and then the least significant 4 bits are the 1s. And then this SDA direction is the signal that controls the direction of the SDA line. And then this is just the clock signal. And so what this whole thing generates is it'll give you at the end a temp data output that then gets sent into the decoder and the FSM to be processed.
And for reference, this is our schematic where you can see all the muxes and all the important modules and clocks that we need to get our temperature sensor and 7-segment display working. Okay. So this is our FPGA. So basically, it's currently in addition mode. The 4 anodes are currently in mode input B, input A, and the result. So if we just take an CN, put in a CN, you can see the result is 1. So this is A. I'm currently changing A. This is 1, 2, 3. We can go up to the full F. We will go to 7. So we will change B. As you can see, 1 plus 7 is 8, 3 plus 7 is 10, and 7 plus 7 is 14. We have other modes as well, which will take too long to explain, but we have a total of 16 modes. And in addition to the 16 modes, we have our temperature mode, which can be activated using this switch. And as you can see, it's measuring the correct temperature. It's currently 27 degrees Celsius. You can also see the LEDs shining, showing the 8-bit binary of the temperature. That's all.
So for our original proposition, we were going to implement a new input mechanism, which was going to be a button counter. And then we were going to have like a memory element attached to that, as well as the temperature sensor. But when we got started, we decided that for efficiency's sake, we discovered that we could implement a new output, and we could also modify our decoders, and then we could also have a sequential logic element through an FSM. So basically, we just attacked the temperature sensor and made sure to implement all those for time saving sake, just instead of doing a whole separate other thing. And the reason why we chose the temperature sensor was it just seemed like because it seemed like we could implement a different output on the anodes and using different cathodes. So we wanted to do that instead of the VGA or the speaker.
And one of the problems that we faced while implementing the temperature data was the temperature data gave us really wrong values, even though it worked fine in the previous demo. It just gave us the values like 95 or really large values. After going through many hours decoding our code, we figured out that the SCL was causing this problem. It was basically not specified as an output in the combined system, so it caused us issues. But we ended up just adding it, and then that solved everything. We also had a bit of problem of choosing which inputs based on the test, like when to display the temperature data and when to display the ALU results. We did this using a mux and a case statement. We had to change our inputs into registers and we used some wires for it to work. And that's basically everything we did for this project.